Hello everyone. Welcome back to the video lecture series on Grade Up on the subject Geotechnical Engineering with me Nihal Naveen. In the last video, we learnt about the introduction of geotechnical engineering and soil foundation, and we also went through the syllabus in great detail. We also looked into the weightage analysis in GATE. In this video, we are going to discuss about the basic definitions in the soil, and we are also going to solve some numericals from the previous year GATE and ES papers. So let's begin. The soil properties. The soil must consist of solid with voids in between. Let's assume there is a solid particle. These are the solids and this is the void. This void may be either air or water. So the soil mainly consists of the solid part, the water and air. The next topic is the three-phase diagram. In the three-phase diagram, we first learn about the weight relations and then the volume relations. The weight of solid is denoted by the symbol Ws and the weight of water is denoted by Ww. Weight of air is neglected. So the weight of soil is weight of water plus weight of solid. Now coming to the volume. The volume includes the volume of solid, volume of water and volume of air. Here volume of air is not neglected. So the total volume of voids is volume of air plus volume of water. And the total volume of soil is volume of void plus volume of solid. That comes volume of air plus volume of water plus volume of solid. This three-phase diagram is very important in solving any question regarding to the basic soil properties. Now coming to some of the basic definitions. First, in volume relations, we have void ratio. It is generally denoted by ratio E. That is the ratio of volume of void to the volume of solid. Here we also look to the difference of sand and clay in terms of void ratio. Though in sand the individual voids are much larger, than the clay. But the number of voids in clay is more than the sand. So in total the void ratio is more in clay with compared to the sand. In permeability, the clay has lower permeability because the individual voids are smaller. And the sand has higher permeability. Now coming to the other definition, that is porosity. The void ratio and porosity are together used to find the denseness or looseness of the soil. It is denoted by the volume of void to the total volume of solid, to the total volume of soil, and it is generally denoted by percentage. There is also a relation between void ratio and porosity, which is denoted by N is equal to E by 1 plus E. We will be studying this relationship in great detail in the coming videos. And here we also have to note that the porosity value is always less than 100. Why? Because the volume of soil, will always be greater than the volume of void. Whereas in case of void ratio, this ratio can be greater than or equal to 1. because in the denominator we have volume of solid. From the engineering perspective, void ratio is more important than porosity because volume of solid is taken in the denominator side, and as the solid is incompressible, so it is of more significance than porosity. Coming to the next basic definition, that is degree of saturation. It is denoted by percentage and by the symbol S. It is defined as the ratio of volume of water to the volume of void. Air content. Air content is defined as the ratio of volume of air to the total volume of void. Here we have to note the difference between air content and air void. Air content is the ratio of volume of air to the volume of void, whereas air void is the ratio of volume of air to the total volume of soil. So this value is always less than 100, whereas air content can be greater than 100. Here there is another relation for this, S plus AC, that is degree of saturation plus air content is equal to 1. As we can see that S is volume of water to the volume of void, and air content is volume of air to the volume of void. This is equal to 1. Now coming to the weight relations. The first is the water content. This is defined as the ratio of weight of water to the weight of solid. This is generally expressed in percentage, and it is more for fine grained soil rather than the coarse grained soil. The second is the unit weight. Unit weight are of 5 types. The first is the bulk unit weight. It is denoted by the weight of total volume of soil divided by to the volume of whole soil. That is weight of solid plus weight of water to volume of solid plus volume of water and volume of air. The next is the dry unit weight. It is denoted by weight of dry soil to the total volume. The third is the saturated unit weight. This is denoted by the ratio of weight of saturated soil to the total volume of soil. The fourth is the submerged unit weight. This condition comes when the soil is submerged below the water table. For example, this. In this case, the buoyant force acts upwards. So it is defined as the ratio of weight of submerged to the total volume. Now coming to the fifth, that is the last, solid unit weight. It is denoted by weight of solid to the volume of solid. Here we have to note it is volume of solid and not total volume of soil. Now another question comes in competitive exam, that is comparison of various unit weights. This is the pattern. We can also remember this by using various mnemonic techniques. For example, SSB DS. We know SSB is conducted in the army, so we can learn this mnemonic by SSB Dega Subedar. So the first S stands for solid unit weight, that is the largest. The second S stands for saturated unit weight, B stands for bulk unit weight, D stands for dry, and S for submerged. Gamma submerged is the least, and gamma submerged is gamma saturated minus gamma W, that is unit weight of water. Now coming to our topic, specific gravity. Specific gravity are of two types. The first is the absolute or true specific gravity, and the other is apparent or mass specific gravity. And when it is not mentioned in the question, then we have to consider the true specific gravity. It is denoted as the ratio of weight of solid of a volume to the weight of water of equal volume. Gamma S by gamma W, or rho S by rho W. For inorganic solids, the value of G varies from 2.6 to 2.9, and for organic solids, this value ranges from 1 to 2. So we can see as the inorganic content increases, the value of absolute or true specific gravity also increases. The second is the apparent or mass specific gravity. This is denoted by the ratio of gamma bulk to the unit weight of water. There is a relation between absolute or true specific gravity and mass specific gravity. That is Gm is equal to G plus Se by 1 plus E, where S is degree of saturation and E is the void ratio. Relative density or density index. This is used to denote the degree or packing of the solid in a coarse-grained structure. This is generally defined for coarse-grained structure and not for fine-grained structure, because in fine-grained structure it is very difficult to find the Emax value. That is, in the loosened state we are unable to find the void ratio. Emax is for the loosest state and Emin is for the densest state of soil. Now the ratio is Emax minus E by Emax minus Emin, where E is the natural void ratio of the soil. Now as the value of natural void ratio increases, we can see the numerator decreases. So the relative density also decreases. That is, relative density is inversely proportional to the natural void ratio. Now coming to some of the important values that we have to remember. For Emax, that is in the loosest state, the value is 0.91. This is obtained when the soil is arranged in rectangular or cubical array. We can see it in this structure. And Emin value is 0.35. That is in the densest state. This occurs in rhombohedral structure when the alpha angle is 60 degree. Here we also have a table which denotes the classification of soil according to relative density. As the value of relative density increases, we can see the denseness of soil increases. For 0 to 15 it is very loose, and for 85 to 100 it becomes very dense. Now coming to the basic numericals so that we can clear our concepts. The first question. This question was asked in EAC in 1995. In a wet soil mass, air occupies 1/6 of its volume and the water occupies 1/3 of its volume. We have to find the void ratio of the soil. Let's assume the volume of soil is V. In the question it is mentioned that volume of water, that is VW, is 1/6 of the total volume, that is V by 6, and volume of, it is mentioned that volume of air is 1/6 of the total volume and volume of water is 1/3 of the total volume, that is V by 3. So we have to find the void ratio. Void ratio, that is E is equal to volume of void to the volume of solid. Now volume of void is volume of air, that is VA, this is VW. That is V by 6 plus V by 3, that is V by 2. and volume of solid is total volume minus volume of void. This is also V minus V by 2, that is V by 2. So this ratio comes V by 2 to V by 2, that is 1. So the correct answer is option C, 1. Next question. This question was asked in GATE in the year 1999. A soil sample in its natural state has mass of 2.290 kg and a volume of 1.15 into 10 to the power minus 3 meter cube. After being oven dried, the mass of the sample is 2.035 kg. Now it is given specific gravity of soil is 2.68. We have to find the void ratio of the natural soil. Now it is given specific gravity, that is G, is unit weight of solid to the unit weight of water. 2.68 is equal to unit weight of solid, and unit weight of water, as we all know, is 9.81 kilonewton per meter cube. So gamma S is 26.29 kilonewton per meter cube. And unit weight of soil is weight of solid to the volume of solid. It is given as 26.29. Now volume of solid. We have to obtain the volume of solid. This value comes 0.75 into 10 to the power minus 3 meter cube. Now as we have to find the void ratio, that is E, volume of void to the volume of solid, we have to find volume of void. This will be equal to total volume minus volume of solid, that is total volume is this in natural state, 1.15 minus 0.75 into 10 to the power minus 3. This value comes 0.4 into 10 to the power minus 3 meter cube. Now we have obtained the volume of void, and we have also got the volume of solid. So the ratio is E is equal to 0.75 into 10 to the power minus 3 divided by 0.4 into 10 to the power minus 3. This ratio comes 0.53. So the correct option is D, 0.53. Now coming to the next numerical, the question. This was asked in GATE in the year 2016 in set 1. The porosity N and the degree of saturation S of the soil sample are 0.7 and 40% respectively. In a 100 meter cube volume of the soil, the volume of air expressed in meter cube is. Now coming to the basic definition of porosity. N is equal to volume of void to the total volume. This is given as 0.7 is equal to volume of void, and the total volume it is given 100 meter cube. So 100. This volume of void comes 70 meter cube. Now degree of saturation. Degree of saturation S is volume of water to the volume of void in percentage. And it is given as 0.4 or 40% you can say. Volume of water to the volume of void that we have obtained here, 70. So volume of water comes 70 into 0.4, that is 28 meter cube. Now we have to get the volume of air in meter cube. Volume of void is volume of air plus volume of water. So volume of air is 70 minus 28. This value comes 42 meter cube. This is the answer. So that's all for this lecture. In the upcoming lecture, we will be studying about different relationships in these soil properties, and we'll also be solving the numericals which are asked in previous year gates to have a greater concept, to build our concept and have a greater insight into the topic. You can also attempt free quizzes and in all topics at GradeUp and get all your doubts cleared. We are here at GradeUp to help you always and be a grade higher. Thank you.